You cannot really compare the trajectory of scientific progress in antiquity and in the modern era, because, first of all, the civilization of the modern era is built upon the foundations of antiquity. And second, the pattern is not the same. You can have the 19th century level of technology in one field and the 15th century level of technology in another. The problem here is that people don't quite understand the level of technology in ancient Rome at all, and usually assume that it was something comparable to the so-called Middle Ages. That's wrong, and how this deep misunderstanding emerged is a separate subject. For this video, I picked 10 wonders of ancient Roman technology, which show us a very interesting picture of Rome, a picture of a civilization which essentially entered the industrial era. Let's go. The Antikythera Mechanism. The most interesting thing about the Antikythera Mechanism is that this artifact could be invented only in the culture with sophisticated mathematical and engineering schools. Only one mechanism was recovered in the year 1901 near the Greek island of Antikythera, but you can be sure that it wasn't some prototype built by an enthusiast. There were more mechanisms, and their production is impossible without proper scientific tradition. The Antikythera mechanism is essentially an analog computer. It is composed of over 30 bronze gears, originally housed in a wooden box. It also included several dials on its exterior. These dials and gears work together to model the movements of celestial bodies. The mechanism could predict solar and lunar eclipses, track the phases of the moon, and even model the irregular orbit of the moon caused by its elliptical path around the Earth. All of this with astonishing precision. Something more or less comparable, the astronomical clocks, was invented only during the Renaissance. Obviously, the Antikythera mechanism is usually placed under the ancient Greek technology label, which is true, but currently it is believed that this device was built in the 1st century BC, which makes it both Greek and Roman. Automatic doors of the Temple of Serapis. This one can also be classified as a Greek invention, but Heron of Alexandria, who constructed the doors of the Temple of Serapis in the 1st century, obviously lived in the Roman Empire. The doors of the temple are notable for being the first known automatic doors in history, and not only automatic but hydraulic doors. The mechanism worked by utilizing heat to create pressure, which in turn moved the doors. The process began when a fire was lit on an altar in the temple. As the fire heated the air inside a closed vessel hidden beneath the altar, the air expanded and was forced through a series of tubes connected to a water reservoir. The expanding air pushed the water into another vessel, which was weighted on a balance system attached to the temple doors. As the water shifted from one vessel to another, the changing weight on the balance caused the doors to slowly open. Once the fire was extinguished, the air in the vessel cooled, causing the water to flow back to its original container and the doors to close. The doors were not the only Heron's creation. It is believed that he constructed a number of steam-powered devices, automated fountains, mechanical birds, and some kind of a vending machine. Water mills. A significant part of this video is dedicated to hydraulics and the overall mastery of the power of water, something at which Romans and Greeks, as we can see, really excelled. Water mills are not a very popular subject of discussions about ancient Rome, which is a shame, and probably a direct disinformation. Most people never heard about the ancient Roman mill complex in Barbegal, in the south of France, or about comparable facilities like the Hierapolis sawmill, located in modern-day Turkey. Barbegal mill, which was probably built in the 2nd century, is not just, a mill. It is an actual factory, an industrial complex. And we don't know how many of these complexes there were in the Roman Empire, and how many people were employed at the factories of Rome. But you can imagine the implications of all of this for the economy. So the site at Barbegal consists of a series of 16 water wheels arranged in pairs down a hillside. The wheels were powered by a continuous flow of water diverted from a nearby aqueduct. As the water flowed down the incline, it powered the wheels in succession, with each wheel driving stones used for grinding grain into flour. The current estimates show that the mill could produce around 4.5 tons of flour per day, enough to feed a population of 10 to 12,000 people. Another great example of how water power was used is the Hierapolis sawmill, built in the 3rd century. This structure used the water wheel to power a saw capable of cutting stone and timber. The water wheel obviously was positioned in a nearby water source and used the natural flow of water to rotate. This rotational movement was then transferred to a mechanical system that converted it into linear motion. The mechanism had a crank and connecting rod system, which allowed the saw to move back and forth in a straight line, similar to modern saws. The sawmill was likely used for large-scale cutting operations in the region. Dams and canals. Yes, Romans obviously built dams and canals. Naturally, Roman dams were constructed primarily to store water for urban use, agriculture, and industrial purposes, as well as to protect settlements from flooding. And as you can imagine, one of the most important uses of dams was to support the aqueducts, because we're talking about the system. Additionally, some dams were used in mining operations, specifically in hydraulic mining, where controlled bursts of water were used to erode soil and expose valuable minerals. The dams were typically constructed using stone, concrete, and rubble, often with a facing of dressed stone to provide additional strength and durability. Which is once again quite obvious, but I have to mention this to stress once again the importance of Roman concrete, which made all the construction works possible in the first place. Several Roman dams have survived or left remnants that provide insight into their engineering capabilities. One of the most famous is the so-called Proserpina Dam near Emerita Augusta, modern Merida, Spain, which created a large reservoir that supplied water to the city via the aqueduct. Another dam near Merida served a similar purpose and is notable for the fact that it is still partially in use up to this day. Since we're on the subject, as a side note, I'd like to mention the canals, and one canal in particular, because people sometimes choose to ignore it, which twists our perception of antiquity. I'm talking about the Canal of the Pharaohs, linking the Nile River with the Red Sea. So yeah, Egyptians and later Romans had their own version of the Suez Canal. The modern canal was opened with a huge pomp in 1869. It was a construction project of incredible importance and immense cost, a marvel of engineering. But there was a canal in antiquity. It was probably completed by Darius I. And I mentioned it in a video about Roman technology because, first of all, Egypt became a part of the Roman Empire. And second, even though the initial canal was Egyptian, or Persian, depending on how you look at things, the Romans were improving the existing system, most notably under Trajan. Aqueducts. And now we're talking about probably the most impressive achievement of the Roman engineers, the aqueducts. The thing is frequently deeply misunderstood. People see the remains of the structures towering here and there with these impressive arches and stuff. That's only the visible part. But an aqueduct is an iceberg of sorts. You cannot really see the whole picture because it is a complex system which is largely hidden under the ground. The most impressive feature of the aqueducts is inhuman scientific precision. Most Roman aqueducts operated using gravity, allowing water to flow naturally from higher elevations to lower ones. The engineers constructed channels with extremely gentle gradients, often just a few centimeters of decline per kilometer. The aqueduct could easily bring water from sources as far as 100 kilometers. Out of all the aqueducts, I'd like to mention the famous Pont du Gard in France, because it tells us a very revealing story. So this Pont du Gard is an aqueduct bridge constructed during the reign of Claudius, which used to be a part of the system that transported water over 50 kilometers to the city of Nemausus, modern-day Nîmes. The slope of the structure was 34 centimeters per kilometer, which is a fantastic precision. Later, when the empire collapsed, the technology was lost and Pont du Gard was used solely as a bridge. And it is standing up to this day. It also must be mentioned that some of the aqueducts, like the one near the city of Cologne, are currently partially integrated into the contemporary water supply systems. Because if you can restore and clean the aqueducts, they are still good enough for use in modern times. They are efficient, they comply with the modern standards, and the planning of the networks, the whole design of the system is near perfect. Sewers and Cloaca Maxima. Obviously, you can imagine the implications of having a functioning water supply system. Romans had running water in public toilets, a thing absolutely unimaginable even in the early 19th century Europe. Well, that's two separate unimaginable things, actually, running water and public toilets. That's one of the reasons why historians of the 18th and 19th centuries launched this gross myth about dirty Romans passing the communal toilet sponge around. Another side note, Romans also invented underfloor heating, because if you have water supplied to your house and you have something to heat it, you can just put the pipes under the floor and there you go. But let's get back to the toilets. Rome also had probably the earliest sewage system, the Cloaca Maxima, the Great Sewer. It is believed that it was initially built around the 6th century BC as an open canal that drained the marshlands between the city's hills, but gradually evolved into an underground system. So Cloaca Maxima was draining water from the city streets and removing waste from homes, public baths, and latrines. Its main channel, which is still partially functional today, ran through the heart of Rome, eventually emptying into the Tiber River. Over time, the network expanded into a vast web of underground tunnels. Naturally, the Cloaca Maxima was connected to the system of aqueducts, meaning that the aqueducts brought fresh water into the city and the sewers removed the waste, creating a continuous flow that helped to keep the city clean, or relatively clean, clean by the 19th century standards. Yes, the system had its flaws because the waste was still ultimately dumped into the Tiber River, which led to pollution downstream. But once again, we're dealing with the 19th century technology here. The road system. You all know the phrase, all roads lead to Rome. What does this phrase mean? Well, it means that a long time ago, all roads literally led to Rome. That's how the system was designed. The Roman road system was crucial for both governance of the empire and its expansion. It is estimated that there were 400,000 kilometers, 250,000 miles, of roads with approximately 50,000 miles paved. And who was actually building them is quite an interesting story, because the labor was provided primarily by the Roman legions. And yes, Roman legions are frequently misunderstood as well, because it wasn't some medieval army roaming here and there. It was a highly disciplined military unit that specialized not only in warfare, per se, but also in engineering. As the legion was moving into the new territories, it was building roads, connecting the army to the supply chains and making the fast advancement of reinforcements possible. They also built all kinds of fortifications and camps, and stationary permanent camps gradually evolved into colonies. You already had a small town where you could transport colonists using the road. So the legions expanded the infrastructure of the empire. The roads themselves were often quite complex. Romans followed a standardized design, starting with a foundation of heavy stones, followed by smaller stones, gravel and sand, all topped with large stone slabs or paving stones. This multi-layered construction ensured durability, drainage, and ease of travel in all weather conditions. The roads were also slightly curved to allow water to run off to the sides, preventing flooding and erosion. Some stretches of the paved Roman roads still survive today. Limes is the further development of the idea of a legion building roads and fortifications. Essentially, it is a system of frontier defenses. And once again, the word system must be emphasized. The greatest example of limes is the so-called limes Germanicus, which spanned from the North Sea to the Danube River, which is more than 500 kilometers. Essentially, it was a number of outposts, walls, forts, and watchtowers, etc. All of them were connected into a well-thought system with the roads and everything. Nobody knows exactly how this particular system worked, since we don't have sufficient data. But what has been excavated is very impressive. Romans started to construct the system at the time of Augustus, constantly upgrading it. Most notably under Tiberius and then under the Flavians. Limes Germanicus was designed to withstand prolonged sieges. It housed a rather large garrison of troops and helped the empire to maintain control over the region. It was a much more impressive and much more well-thought structure than the Great Wall of China. The Great Wall just has a better PR and has impressive photogenic segments built in the 20th century. Restored in the 20th century. Obviously, there were other limiters in the empire, and the Brits will gladly tell you marvelous stories about Hadrian's Wall. Indeed, it looks very impressive in the Assassin's Creed Valhalla video game. But it is mostly a fantasy wall. It doesn't serve any serious strategic purpose. So British historians come up with explanations that, yes, it wasn't so much about the protection of the region, but more likely a boundary where you could place customs and enforce taxation of, sheep from Caledonia. Forget about the wall attributed to Hadrian based on one broken inscription, or the Antonine Wall. The system in Germany is what really reveals the genius of Roman military engineering. Pantheon. The Pantheon in Rome is the pinnacle of architectural achievements of Romans and an ode to Roman concrete, a material that was replicated only in the 19th century. The original temple was built by Agrippa during the reign of Augustus. That's why his name is on the building up to this day. But this temple was destroyed in fire and rebuilt by Hadrian. The main feature of the Pantheon is its incredible dome. It is 43 meters in diameter, and it was the largest dome in the world until 1436, when the dome of the Cathedral of Santa Maria del Fiore was built in Florence. But the Duomo of Florence was built using a different technology, and it looks different. The dome of the Pantheon is a perfectly symmetrical sphere, or a half of a sphere, made of unreinforced concrete. with the oculus in the middle, which lets the rays of the sun inside, and the whole temple could work as some sort of a gigantic sundial. The oculus is the only source of natural light for the interior, and in fact, it also lightens the load of the dome's apex, reducing stress on the structure. It is actually a very complex technology. The thickness of the dome decreases as it rises, going from 6 meters thick at the base to just 1.2 meters at the oculus. Lighter materials were used in the upper levels to further reduce weight. It is an actual architectural wonder, but people sometimes just don't understand how hard it is to build a super large dome and what kind of technology and engineering genius it takes to construct something like that. Let's just put things into perspective. The dome in Florence was built in a very different manner, although it is still very impressive. It happened in the middle of the 15th century, and we don't know how long it took to construct the thing. Officially, the dome took 16 years to complete. And the whole cathedral has a fantastic backstory. It is said that it took a total of 140 years to complete the whole thing, which is... Okay, now the prominent domes of the 19th century. The dome of St. Isaac's Cathedral in St. Petersburg is larger in scale compared to Pantheon, rising to more than 100 meters, but the diameter of the inner dome is around 25.4 meters, which is substantially smaller. It took 40 years to complete the cathedral. The project was finished in 1858. 40 years. Twice the reign of Emperor Hadrian. Then we have the US Capitol building. The dome is 29 meters in diameter. Took 11 years to complete, finished in 1866. Once again, the dome of the Pantheon, 43 meters. Took 4 or 5 years to complete. We don't know when it was finished, but probably in the year 125. 4 or 5 years. I also have to mention that originally the dome was covered in bronze, but Christians stripped the dome from bronze in the 17th century. They needed it for construction works in the Vatican. And Hadrian, well, the Pope chose the mausoleum of Hadrian as his residence. That's a deeply disturbing story if you think about it for a minute. The Temples of Baalbek. Since we mentioned the Pantheon and its dome, we should talk about the Temples of Baalbek. Baalbek is the modern name. The city was known as Hierapolis in Roman times. It is the territory of present-day Lebanon. The complex includes 3 primary temples: the Temple of Jupiter, the Temple of Bacchus, and the Temple of Venus. The Temple of Jupiter, in particular, is usually referred to as the Temple of Baalbek, singular. Hierapolis used to be an important Phoenician city. The transformation of the religious complex started under Augustus, with the main temple finished much later, somewhere in the middle of the 1st century. And then they were constantly upgrading everything, most notably under Trajan. So what's so important, so jaw-dropping about this temple complex? It is mostly the ability of the Roman architects to work with massive objects. The columns of the Temple of Jupiter were 20 meters tall, and each of them weighed approximately 60 tons. 6 columns remain standing. There were more than 50 of them. But that's not all. The foundation of the temple has massive stone blocks. The 3 largest blocks, known as the trilithon, each weigh around 800 tons. And they were placed there with incredible precision. Just to put things into perspective once again, in the year 1586, the so-called Vatican obelisk was moved 250 meters from one place to another, the St. Peter's Square. This is a very large obelisk, 25 meters tall and made of granite. It weighs over 300 tons. It was the first obelisk to be moved from one place to another in the modern era. Nobody even tried to accomplish something like that before the year 1586. In order to move this thing, the architect Domenico Fontana had to devise an elaborate method, which he later described in detail. It took a few months of preparation, about 1,000 people, more than 70 horses, and building rails. It must be noted that this obelisk was brought from Egypt in the times of Gaius Caligula. So they moved it into a ship, brought it to Rome, and started moving it around, and then placed it in the circus, the horse track. And roughly at the same time, they were moving 800-ton blocks in Hierapolis, moving them, cutting them, assembling them with precision. But yeah, there was obviously a limit to Roman capabilities. There are some other monoliths found at Baalbek. The largest is 1,500 tons. So apparently Romans decided not to use this one. Too heavy, even for Romans. That's all for today. I hope this list changes your perception of ancient Rome a little bit. In the beginning of this video, I've said that we see a picture of a civilization which essentially entered the industrial era. And I wasn't joking. Thank you for watching. Don't forget to like, subscribe, and give this video 5 stars. Also, please don't forget that I have this beautiful Oedipus/Antigone visual novel game I made. It is available on Steam, link in the description. And I also have a nice soundtrack for the game and a bunch of industrial metal albums of debatable quality. See you soon.